let's try a couple more. If you look at the next example, the probability that a person in the U.S. has O positive blood is 38%. 3 unrelated people are selected at random. So on this one, we're looking at selecting 3 unrelated people. And we, again, want to determine if 2 events are complements. So we're going to end up listing the sample space again. But this time we're dealing with 3 people and whether or not they have O positive blood. Well, let's look at the first event. The first option is none of the 3 have O positive blood. That's your first option. It could be that 1 has O positive blood of the 3. It could be that 2 people that you selected have O positive blood. We only selected 3 people, so your best case scenario is that all 3 have O positive blood, but that's at most what you can get. So let's take a look at our events here. Event A is that none of them have O positive blood. That is only this first option here that we'll include there. So that's our A. Event B is that at least 1 has O positive blood. Again, just like a couple problems ago, the key is that at least 1 means 1 or more. So 1 or more means I'm going to include that if only 1 has O positive. I'm also going to include if 2 have O positive because that's more than 1. Or even all 3 could have O positive. That's also going to be included. So all 3 of these last ones are going to be included in event B. So then the question becomes, are these 2 complements? And the answer is absolutely yes. Because either you're in A or you're in B. They don't overlap. There's nothing left out of the sample space that isn't in either A or B. So yes, everything is covered in A or in B without any overlaps. Okay. Here's a couple more. 12 light bulbs are tested to see if they last as long as the manufacturers claim they do. 2 light bulbs are selected without replacement. So 2 light bulbs, that's what we're looking at. Well, let's list out, we're going to determine whether or not things are complements or not. So let's list out our sample space again. But again, we're just dealing with 2 light bulbs and whether or not they pass or fail. So one option is that they both pass the test, whatever it is. And the next option is you could have 1 pass, but that also means that 1 fails. And last option is that both of them fail the test. So if we look at event A on this first one, event A is that both bulbs pass the test. That is only option 1 on our sample space, or possibility number 1. That is that both pass. Notice event B, however, is that both bulbs fail the test. That is just number 3. So the question is, are these 2 events complements? And the answer is no. Why is it no? Is because the option of having 1 pass and 1 fail here, number 2, is not included in A or B. Number 2 is left out. It's not in A or in B. So they can't be complements or opposites because there are things left out. Let's do one more. Again, it's the same different events, C and D, but the same situation, so we can just rewrite out our same sample space. Our same sample space would be either that, again, both could pass, or you have 1 passes, 1 fails, or you could have that both fail. So let's take a look at event C. Event C is that both bulbs pass the test. So both pass, that's just possibility number 1. Let's see what event D is. Event D, however, is that at least one light bulb failed the test. At least one means at least one failed means one or more failed. So one or more failed. So let's take a look at that. And option number 2, or possibility number 2, you do have one fail. So we will go ahead and include that in our event D. And having at least one fail does mean that both could actually fail. So both of these are included in your event D. So are these two events complements? Yes, because this is the first time for this example that both C and D do cover all the sample space. There's nothing left out, and there's no overlap between the C and D. There's nothing left out of C or D from the sample space. So this is a perfect example of two events that are complements.